This problem has several parts. The first part is to find the vertex, and you have to type your answer in as an ordered pair. So we're going to use our formula for finding the vertex, which is x equals negative b over 2a. That'll find the x coordinate of your vertex, and then we can just substitute that into our function here to find the y coordinate. So b is the coefficient of the x, and since we want to make that negative, it's negative 11. And then we do 2 times a, and in this case the a is the a is always the coefficient of x squared. In this case it's a 2. So we have a positive 11, negative 11 is positive 11 over 4. Now that's only half of our vertex. That's the x coordinate. So we have to take that and we have to plug it back in to our function wherever the x is to find out what y equals. So y equals 2, and instead of an x squared here, I'm going to put in 11/4. I'll square that. And then instead of an x here, I'll put in the 11/4. And then the last term doesn't have an x. So we have to solve this so that we can get the y coordinate. And then that will give us our vertex. Our vertex will be 11/4, comma, whatever this turns out to be for our y. And this is how we're going to put it into my math lab to get the correct answer. So if we square this, squaring 11 is 121. Squaring 4 gives you 16. So that's 121 times 16. And we're going to double that, because it's times 2. And then we have 11 times 11/4. I guess I could have gone ahead and done that. 11 times 11 again is 121. So 2 will go into 16 8 times. So that'll save me a little bit of trouble there. I won't have to double my 121 and then simplify anyway. So I have 121 over 8 equals minus 121, because I have 11 times 11 there again, over 4 plus 5. So I need these 121s over 8 and over 4. I need them to have the same denominator. So the way that I can get that is to multiply this by 2. That'll give me 8 for denominator on that. If I do that, I have to multiply the numerator by 2 also. Otherwise, I've changed the value of that fraction, and that just ruins everything. So we can't do that. So we have to make them both, change them both by multiplying by 2. 121 over 8 now, minus, that'll be 242 when I multiply that by 2 and then over 8. And I'm going to go ahead and change my 5. It's 5 over 1, but I want it to be over 8 also. So I might as well multiply both the numerator and the denominator by 8 so that it also is a fraction with a common denominator. So I have 40 over 8. And the reason I left this all in fractions is because it tells us to use integers or fractions for any numbers in the expression. So I want to keep it as a fraction. So when we combine all this, 121 minus 242, that gives us a negative 121. And then we're going to add to that 40. And that's going to give us a negative 81 over 8. And that's what our y coordinate is. And now you have your vertex. The second part of this question asks you to find the x-intercepts. To find the x-intercepts, you plug 0 in for y. Then we're going to have this quadratic equal to 0. And the easiest way to solve for that is to factor it. So that's what I'm going to try. If it doesn't factor, then we could do the quadratic formula. But I think this one's going to factor. If it factors, we need 2x and x to get 2x squared. Looking at the last term, we've got plus 5. So that means the signs have to be the same to get a positive number when you multiply. And so we look at the center term, the middle term here, to see what the signs will both be. And they're both going to be negative or minus. And then 5 only factors one way. 5 times 1. Whatever that we put in this space gets multiplied by the 2x. And then whatever we put in this space gets multiplied by the x. So if we put our 5 here, we're going to get a negative 10x. And then we'll put the 1 here and we'll have a negative 1x. And together, they'll add up to our negative 11x in the middle. And that's what we're wanting. So we've got this factored correctly. You can do your FOIL method to multiply it back out to double check that. And then we're going to take each factor and set it equal to 0. If you have two numbers like this is a number, and this is a number. If you have two numbers that are multiplied together and you get the answer to be 0, one of those has to be 0. That's the zero product principle. So that's what we're using here to solve this. That's why we set each factor equal to 0 to see what would make that 0. So if we add 1 to both sides here, we'll have 2x is equal to 1. And then we can divide both sides by 2. So x could be a half, or if we solve this one, we can get x to be equal 5. Now, once the x-intercept's also entered in as an ordered pair, so we know that x coordinate of each, because we just wrote those down. Now the y coordinate, if you remember, we started by substituting in 0 for y. So that's what we put in for our second half of our x-intercept. So a 0 for the y. The third part, they ask you for your y-intercept. And you do just the opposite of finding your x-intercept. For the x-intercept, we plugged in 0 for y. For the y-intercept, we'll plug in 0 for our x's. We'll put zeros in here and here. Now when we multiply that 2 times 0, we get 0. 11 times 0, 0. Plus 5. So what y is going to equal is 5. And again, put it in as an ordered pair. We used 0 for x. We found out y was equal to 5. After you've gotten all these parts done, your x-intercepts, your y-intercept, your vertex, you're going to get a series of pictures to choose from, graphs. See which one matches the points that you have, because you'll have several points now. And let me know if you have any more trouble with this problem.